Hello, my dear friends. How are you all? I hope you all are fine. So, you are very welcome in a lecture number 1 of playing with numbers. So, I hope you will enjoy this lecture. So, this lecture and this chapter is going to be very amazing because in this chapter we are going to be play with numbers, okay, and we are going to be see a lot of tricks and puzzles and lot of things, okay. So my dear friends, you have to be listen very carefully, okay. Yes, now let's start without wasting the time. Yeah, so today here we are going to discuss about the introduction of playing with numbers, okay. Introduction of playing with numbers. Now we know that numbers are quite amazing to play with, okay, and we can enjoy several tricks with them, and we can reverse the digits and we can play with them, okay. So there are a lot of amazing tricks and a lot of amazing puzzles in this lecture we are going to be discuss, okay. Yes, now let's see what is the general form of numbers. What is the general form of numbers? Now we come across numbers every day in our life, we know that very well. We buy our commodities with money and measure its quantity. So money and quantity, all these are simply done with the help of numbers. So numbers play an important role in our daily life. Therefore, number plays a very significant role in our life. Got it? So there are many types of numbers used in the number system based on convenience and requirements. Okay. For example, integers, whole numbers, natural numbers, etc. There are a lot of types of numbers, so which are often used for classifying different things around us. I hope my dear friend understand these things. So here you can see, if you talk about the natural numbers, what is natural numbers? A natural numbers is any positive numbers that is used generally like 1, 2, 3, 4 and so on. So these are the number which is starting from 1 and ending up to infinity. So this is represented with the help of capital N. Okay. Now if you talk about the whole number, what is whole number? Whole number include all the natural numbers along with 0. Okay, in this it is starting from 0, 1, 2, 3 and so on till infinity. Got it? And it is represented by W. I hope you understand these things. Now an integer is any number which can be written without a fractional component. Without a fractional component. Okay, so it belongs to a set of numbers that include positive and negative numbers along with 0. It means here is in integers, all the numbers which can be represented on a number line are the integers. Like here you can see 0, 1, 2, 3, 4 and so on till infinity, and on in the left it is -1, -2, -3 and so on. So these are the what? These are the integers. Okay. Yes. So here is, you can see that here is positive integers and here is negative integers. Got it? Understand? Yes. Now here is that representation of numbers in general form. In what? In general form. Okay. Now let's see the general representation of a number for the two-digit number. Okay. So here is, let's suppose we have two-digit number A, B. This is our two-digit number. Okay, and the general representation of this number is A into 10 plus B into 1. Here you can see that this AB not means A into B. Okay, listen to me very carefully. This AB is not equals to A into B. It means this is two-digit number. Like here you can see this may be 11, this may be 12, this may be 99. Okay, we know that two-digit numbers are starting from 10 to 99. Okay, so the general form of 2-digit number is A into 10 plus B into 1. Okay, understand my dear friends? So this is what? This is the general form of 2-digit number. If you see the example here is, let's suppose we are taking the 95. Got it? Yeah, so we can write 95 as here. Here you can observe this. We can split this like 90 plus 5. Okay, 90 plus 5, and we can split 90 as 9 into 10 plus 5. Okay, into we can write into 1. So if you observe this, here is A is what? A is 9 and B is 5. So plus 5 into 1. So this is what? This is the general representation of 2-digit number. Okay, I hope my dear friend you understand these things. So this is very easy. You just have to understand. You just have to learn this part. This part, general representation of 2-digit number. Simply it is, we can write simply like AB is equals to what? A into 10 plus B into 1. Okay. If you see the another example, here we can write. Let's suppose 12. We have to write the general representation of 12. So again we can write. This is very easy. So we can write 1 into 10 plus 2 into 1. This is the answer. Okay, I hope you get this point. Yes, now let's see the general representation for a 3-digit number like ABC. Okay, so here we have 3-digit number, capital A, capital B, capital C. Okay, so the general representation of this is here you can see A, B, C. We can write it as A into 100 plus B into 10 plus C into 1. This is what? This is the general representation of 3-digit number. So we can express any 3-digit number in this form. What? Yes, in this form. Now if you see the example, here you can see that. Now the example is, here you can see. Let's suppose we have to write the general representation of 123. So now we can split 123 as 100 plus 20 plus 3. Okay, so here we can write 1 into 100 plus 2 into 10 plus we can write 3 into 1. Simple, that's it. This is the answer. This is what? Yeah, this is the answer. Here you can see A, B, C. Here A is what? 1, B is 2 and C is 3. So A into 100 plus B into 10 plus 3 or we can say C into 1. Okay, so this is again very easy. So you can write the 3-digit number like this form. So you can write any of the 3-digit number in this form. Okay, let's suppose 456 we are writing it. So we can write it as 4 into 100 plus 5 into 10 plus 6 into 1. This is very simple. Okay, I hope you understand these things, my dear friends. Yes, now let's solve some problems. So here is, write the following numbers in generalized form. Okay, so here we have first part is AB. Okay, so this is very easy. So we can write first part as AB is equals to, we can write it as, this is what? This is 2-digit number. So this is A into 10 plus B into 1. So we can write it as 10A plus B. What is 10A plus B? Now next is we have 85. This is again 2-digit number. So we can write 8 into 10 plus 5 into 1. So this will become like, here you can see again we can, this will reverse process. So this is 80 plus 5. So if we add here we get, this is 85. So we can check hand to hand directly. Okay, so this is the generalized form. Okay, now if you see the next part which is 132, so we can write it as 1 into 100 plus 3 into 10 plus 2 into 1. Got it? Understand, my dear friends? I hope you understand these things. Yes. Now D part is like here we have to write the general form of 1000. So here we can write 1000 into 1. Just this is the general form. Okay? Yes. Now in this case, here in this question, now we have to write the following in usual form. Here we have an expression. Here we have to do the reverse process. Here we have the general form and we have to write in the usual form. Okay. So here you can see that 3 into 100 plus 0 into 10 plus 6. So if you write this, just solve this. Okay. 3 into 100 is what? 300 plus 0 into 10 is what? 0. Okay. Plus 6 is what? 6. Okay, understand, my dear friend? So now here we can write it as 306. This is what? 306. Okay, now the next one here you can see. Now here we have 5 into 1000 plus 3 into 100 plus 2 into 10 plus 1. Okay, simply we just have to solve it. So 5 into 1000 is what? 5000. Plus 3 into 100 is what? 300. Plus 2 into 10 is what? 20. Plus 1. So after adding this, here we get 5, 3, 2, 1. So this is what? Yeah, this is the usual form of this general expression. I hope, my dear friend, you understand these things. Yes, now the next question here you can see that. So here is the product of two digit numbers is 1431. Okay, it means 1431. Now the product of their tens digit is 10 and product of their units digit is 21. Now we have to find the numbers. What are the numbers? So here is first of all. So now suppose we are taking the two digit number. Let the two digits numbers be. Here we are taking 10a plus b and 10p plus q. This is the generalized form. This is the general form of two digit number. So first two digit number is this and the second two digit number is this. According to this problem, here the product of these two digits is what? 1431. So we have to find the digits. Now how we can find it? So here we have, it is given that the product of their tens digit is 10. It means tens digit is what? This is the tens digit a and here p is the tens digit. So according to question, a into p is what? 10. Okay, a into p is what? 10. And here again the product of their unit digit. So this is what? This is the unit digit. So b into q is what? This is 21. This is what? 21. So we have two conditions, which is a into p is 10 and b into q is 21. Okay, now we know the factors of 10 is what? Here if you observe the factors of 10 is 2 into 5. Okay, or it may be written as 5 into 2. So the value of a and p is 2 and 5 or 2, 5 and 2. It means the value of a is 2, then the value of p is 5. If the value of a is 5, then the value of p is 2. So we have the value of a 2 and or 5, 2 or 5. So the pairs like here is, you can see that a is equals to 2 and p is equals to 5. Or one pair is the other possibility is a is equals to 5 and p is equals to 2. So there are two possibilities. Similarly, here if you observe this, b into q q is 21, and we know that the factor of 21 is what? 3 into 7, or we can write 7 into 3. So again there is a two possibilities of b and q. So if b is 3, then q is 7, or the other possibility is b may be 7 and q is 3. Okay, understand? Now similarly we can write, similarly here is b is 3 and q is 7, or if b is 7 then q is 3. Okay, understand my dear friends? I hope you get this point. So now we are putting the values of a, b, p, q in this problem, in these digits. Okay, got it? Now here we are going to put these. So here we have 10a, okay, 10a plus b, and we have 10p plus q. Now we are taking, in this case we are taking, here is a is equals to, here you can see we are taking a is equals to 2 and b is equals to, here is we are taking b is equals to 3, and here is, in this we are taking, so p will become like, if a is equals to 2, here is, if a is equals to 2 then p is 5, then p is what? Then p is 5. And if b is equals to 3, here is, if b is equals to 3 then q is 7, then q is what? Then q is 7. Okay, now put the values. So here is, you can see that 10 into 2 plus 3, this will be 23. Okay, and in this case 10p plus q, in the case of 10p plus q, here is 10 into 5, this is plus 7, this is 57. This is what? 57. Now we are changing the values. Now we are going to put the value a is equals to 5 and b is equals to 7. Now here we are taking p is equals to 2 and q is equals to 3. Now put the values. Now if we put the values in this equation, here we get, if 10 into 5 plus 7, this will become 57. Now in this case 10 into 2 plus 3, this is 23. So now here we have the pairs, like here we have a pairs are numbers are, here is 57 and 23 and 23, or the another pair is, okay, so the pairs are what? 27 and 57 and 23, and here is the other pair is 23 and 57. Okay, so but if you multiply these two, we get the same result, okay. So now here is, you can see that now the other pair is, now in the next, here for finding the other pair, other different pair, we have to take a is equals to 2, but we have to interchange the value of b and q. We are taking the same as a is equals to 2 and p is equals to 5, and we have to interchange the value of b and q. Okay, now here let's see, we have 10 a plus b and 10 p plus q. Okay, so now if we are taking, if a is equals to 2, b is equals to, here is, we are taking b is equals to 7, we are taking b is equals to 7, and in this case if a is equals to 2, then p is equals to 5. Okay, and q should be 3. Now put the values. Here we get 10 into 2 plus 7, so we get 27. Here we get 10 into 5 plus 3, so we get 53. Now in this case, here is, if we taking the a is equals to 5 and p is equals to 2 and we interchange the value of b and q, then we get the same result. We get the what? We get the 53 and 27. So here we have the pairs are 27 and 53, and the other pair is here is 23 and 57, or the other pair is 23 and 57, 23 and 57. Okay, so either this is the correct or this is the correct. Got it? Yes. Now let's see which pair is correct. So if you multiply 23 into 57, we get 1311. Okay, and if we multiply 27 into 53, we get 1431. So this is the result. So it means we can say that this pair is correct, because we have to check, we have to find the product of two numbers should be 1431. So this is what? 1431. So we can write hence the required numbers are 53 and 27. So this is what? This is the answer. Now let's see the second method. Okay. Yes. Now method number 2 is here in this case. So here is, now let the two digit number, here we are taking the two digit number is, let the two digit numbers are here is A, B and P, Q. This is what? This is two digit number. Okay, it means this means not is A into B. Okay, this is what? This is two digit number A, B and P, Q, not P into Q. This is P, Q. Okay, so here it is saying that product of tens digit, product of their tens digit is 10. Okay, it means here you can see A into P is what? 10. So A into P is 10, and the product of their unit digit, which is what? B into Q. So this is what? This is 21. This is 21. Okay, now we know that AP is what? 10, and the factors it may be like A should be 2 and B should be 5, or A should be 5 and P should be 2. They are the cases. Got it? Now the other is BQ is what? 21. Now in this case, so we can factorize this 21 as 3 and 7 in the form of 3 and 7. So here is, it means B should be 3, and here is Q, then Q is 7. Or the other case is, if B is equals to 7, then Q is 3. So these are the cases. Okay, so it means with the help of these, the 4 cases is made for finding the digits, two digit numbers. Okay, so what are the cases? Let's see. So there are 4 cases is arise. So here you can see that. Now here we have the different values of A, B, P and Q. So now first of all we are taking the value of A is 2 and B is 3 and P is 5 and Q is 7. So here in this case A is 2 and B is 3. Okay, then P is what? P is 5 and Q is 7. Now in the second case we are taking A is 5, B is 7, P is 2 and Q is 3. So this is like A is 5, B is 7, P is, here is, we are taking, if A is 5 then P is what? P is 2. If B is 7 then P is, yes, P is 3. Okay, so they are the two cases. Now in the third case, we are remaining same the value of a and p. We are going to interchange the value of b and q. Okay, it means this is 2 and this is 5. Now if we interchange the value of b and q, here we get 7 and 3. Okay, now similarly in this case we are remaining same the value of a and p in the second case, like this is 5 and 2, which is same. We have to interchange the value of p and q. So this is what, this is 3 and this is 7. So they are the four cases. Okay, now if you observe this, case 1 and case 2 is approximately similar, because here is 23 and 57, here is 57 and 23. Okay, so they are the same cases. Now case 3 and case 4 is 27 and 53, 53 and 27. This is similar. So the important case is case 1 and case 3. So here is the numbers are 23 and 57, or here you can see 27 and 53. So these are the two cases we have. Understand, my dear friends? So if you multiply 23 into 57, we get 1311. Okay, and if you multiply 27 into 53, we get 1431. So this is what, this is the required two digits number. So here we can write, so required two digit numbers are 27 and 53. So this is what, this is the answer. Okay, so I hope you understand these two methods. Okay, yes. Now the next question is, this is again similar question, so that you can understand very strongly. Okay, yes. So the product of two digit number is 2117. Now the product of their units digit is 27 and that of tens digit is 14. It means the product of their tens digit is 40. Now we have to find the number. Again we have to find the number. Okay, yes. Now again, let's suppose we are taking the two digit numbers are, let the two digit numbers be, we are taking m n and p q. So these are the two digit numbers. Okay, got it? Now here we have mn into pq should be always equals to 2117. Okay, so we have to find mn and pq. Okay, now according to question it is saying that, it is given that here is the product of their tens digit is what, 14. It means tens digit is m and p. So m into p, this is 14, and the product of their unit digit is 27. It means unit digit is n and q. So n into q, this is 27. I hope you understand these things. Okay, so the product of their two digit m into p is what, 14. It means m is 2 and p is 7. Then we know that 2 into 7 is what, 14. There is just only one case. Now the other case is, or it may be m is 7 and p is 2. So there are just two cases, 2 7 7 2. Now in this case, here is, now if n into q is 27, then n should be 3 and q should be 9, because 3 into 9 is what, 27, or n should be 9 and then q should be 3. 9 into 3 is also 7. Okay, understand? Now again there are 4 cases. What are these? Let's see. Here is, now in this, here is, so the first case we are taking 2379. What is 2379? Okay, and next case is 7923. What is? Yes, 7923. Got it? I hope you got this point. Now the third case is here. Here is third case is, here we have to remain the same value as 2 and 7. We have to not change the value of m and p, and we have to interchange the value of n and q. So here is, this is, here you can see this is 2 and 7. So we interchange the value is, this is 9 and this is 3. Now in the similar case, here is, we have to remains the value is 7 and 2, and we have to change the value of n and q, which is 3 and 9. Okay, so these are the 4 cases. I hope. Now the feasible cases are 23 into 79 and 29 into 73. So we can write, so the feasible cases are, here is, okay, so the feasible cases are, here you can see that 23 and 79, okay, or 29 and 73 and 73. Now if you multiply this, here is, if you multiply 23 into 79, here we get 1870. Or if we multiply 29 into 73, here we get 2117. So we get what? 2117. So this is our required result. It means this is our required number. So here we can write, hence the required 2-digit numbers, are 29 and 73. So this is our result. Okay, understand? Yes. Now next problem is, express 3458 in a generalized form. So as we express 2-digit number and 3-digit number, here we can again we can express in the general form of 4-digit number also. How we can generalize it? Let's see. So this is very simple. Here we have 3458. Okay, so 3 into, after 3, how many digits are there? 3. So it means 10 into raised to power 3. 10 raised to power 3. Okay, it means 1000. Got it? Now plus, now 4 into, here is, after 4 there are just only 2 digits. It means we can write 100. Plus, after 5 there is just only 1 digit, so we can write 5 into 10. Plus, now we can write 8 into 1. So this is very easy. So now you can express the general form of any of the digit numbers. Yes, now here is next question. You can see a 2-digit number is such that the product of its digit is 14. Okay, the product of its digit is 14. Now if 45 is added to the number, the digits interchange their places. Now we have to find the number. Okay, yes, so here you can see that, let the digits at units and tens place at units and tens places be x and y respectively. Now the product of their digit is 14. It means x into y is what? 14. Is what? 14. So here from this we can write y is equals to 14 upon x. Let's suppose this is equation number 1. This is equation number 1. So we can write the 2-digit number as, so the two-digit number will be, we can write it as 10. Here you can see that at tens place we are taking the y, so this is 10y, plus at unit place we are taking the x, so this is x, so 10y plus x. Now when the digit will be, here you can see that, okay, now here you can see that if 45 is added to the number, the digits interchange their places. Okay, so now when the digits will be reversed, or we can say will be interchanged, will be reversed, then the reverse number will be, then the reverse number will become, reverse number will be, here is places will be changed, interchanged, so it means this will become 10x plus y, 10x plus y. Okay, so according to question, here we have original number, we have to add 45, we get the reverse number, so original number is 10y plus x, okay, plus 45, and the reverse number is 10x plus y, 10x plus y. Okay, so after solving this, if you solve this expression, here this will become like, here you can see that 10y plus x plus 45, we have to shift, here is this will become like minus 10x minus y is equals to 0, because if we shift these numbers to the LHS, the signs will be changed, and here you can see 10y minus y is what, 9y, x minus 10y, this is minus 9x, got it, and here this is minus 45. Okay, so this will become, if we take 9 as a common, we get 9 into y minus x, and this is equals to minus 45, and this 9 will shift in the RHS in the denominator, so this will become y minus x is what, this is minus 5, this is what, minus 5. So here let's suppose this is equation number 1. Now we know that the value of y is 14 upon x, so we can put the value, so put the value of y from equation number 1. So here we get, if we put, we get 14 upon x minus x, and this is equals to minus y, and this will become, if we take x as LCM, we get 14 minus, this will become x square, and this is equals to minus 5. So now my dear friend, 14 minus x square is equals to minus 5x. Okay, understand? Now we have to shift all these terms to the RHS, so all the sign will be changed, so we get x square minus 5x minus 14, what is minus 14, and this is equals to 0. Okay, so here we have x square minus 5x minus 14 is equals to 0, and now we have to find the factors of this expression. Now we know that in previous chapters we learned how to find the factors of these type of expression. Okay, we have to split the middle part. Okay, so how we can split this, let's see. So x square minus, we can split as, here you can see 7 minus 2. Okay, 7 into 2 is what, 14, and if you solve this we get 5, so this is x minus 14 is equals to 0. Okay, and this will become x square, here is minus 7x, and minus minus plus twice of x, minus 14 is equals to 0. Now my dear friend, here we have to make the regroup. Okay, so here we can take x as a common, we get x minus 7. Okay, from this we can take 2 as a common, we get x minus 7, which is equals to 0. Now here this will become, here again we have two terms, now we can take x minus 7 as a common, we get x plus 2, x minus 7 and x plus 2 is equals to 0. Okay, now for finding the value of x, we have to place each term equals to 0. Listen to me very carefully. So this will become x minus 7 is equals to 0 and x plus 2 is equals to 0. Okay, so we have x is equals to 7 and here is x is equals to minus 2. But here you can see that here we are taking the value of x is equals to 7 because the negative digit means digits cannot be negative. So here x is what? X is 7. Now if x is 7, here is, you can see that from first equation x is what? 7. So y will be 14 upon 7, which is 2. So put the value of x in equation number 1. Okay, so here we get, okay, y is equals to 14 upon x is 7, so here we get 2. Here we get what? 2. Now we have x which is 7 and y which is 2. So the required number is, so required number is, here we know that this is what? This is 10. Here we are taking the 2-digit number is what? 10y plus x. Okay, what is 10y plus x? So here is 10y plus x and here y is 2 plus x is 7. So we get 20 plus 7, which is 27. Okay, I hope my dear friend you understand these things. So this is what? This is the answer of this question. So now this is enough for today and we will meet in the next lecture with the next amazing topic. So thank you very much for listening me and take care and goodbye.